Okay, so first of all, we will sort of understand the theory part here. So Newton's second law of motion, we know that would be F net is equal to ddt of p. P is the momentum, or we can say delta p divided by delta t. So this is rate of change of momentum. Rate of change of linear momentum is proportional to the net force exerted on an object. So when you simplify this one, you get F net is equal to ma. So there is a assumption here, right? What is assumption? So assumption would be mass is constant. So under that assumption only, you can simplify ddt of p equation into F is equal ma. Okay, so Newton's second law is not F is equal to ma, but rate of change of momentum is equal to F external force. But under this assumption, you get F net is equal to ma. Now we have to understand this F net or external force is equal to ma. Now here what we have to understand is we should specify the mass we use this equation, right? So mass should be specified. Mass or the system of masses. System of masses should be specified. So for example, consider you have a mass here m. The net force is to the right, acceleration also to the right direction. So so for this one you can use F is equal to ma without any issues, just F is equal to ma. But if you have a system like this, attached system, so this is m1 m2, so this is pulled with F net, same thing, right? So it's moving in that direction. So in this, for this system, you can use F is equal to ma. Now you have to say F is equal to ma is used for the system. Is used for the system. So when you use this for the system, F on the system would be F net. Mass of the system, that would be m1 plus m2, and acceleration would be a. So this is the this is how we use F is equal to ma for individual objects as well as for systems of objects. So now we briefly understand tension. It's a force we typically denote by T. So what is a tension force? Okay, to understand that, suppose you have a mass here m, and it is pulled by F force. There is another mass, similar mass, pulled by F force. Now these two masses are attached by a string. We call it unstretched string. This string is not going to stretch. Okay, so that means the length of the string is going to hold constant. Now what will happen, due to this pull, there will be a tension force acting on the rope like this. Okay, also according to the Newton's third law, there will be a reaction force acting on that. So you can see these two forces are TT, tension forces, right? 4 tension forces are building here. Now we have to understand this tension force over here, right, acting on the rope. This is acting on the rope, but it is given by the mass. Okay, so these two, okay, acting on the rope, but it is given by the mass. Okay, so now when we draw the tension forces, typically we don't draw all of these forces. So we typically draw only these two. So like this, right? So suppose this is M1 and M2, right? So this is F1, this is F2, right? So the tension force is this. So this tension force, tension force is given by M2 mass on the rope. The other T is given by M mass on the rope, right? So if you consider the system, right? If you consider the system, okay, internal forces are considered to be tension forces are considered to be internal forces. Tension forces are considered to be internal forces. So why they are called internal forces? Why? Because you consider the whole system. So that means you consider this system. So you consider this system as one object. You consider this system as one single object. Okay, system, right? Consider as one single object. So this is M1 and M2. Now we will think about the free body diagram. What do you mean by free body diagram? Free body diagram means we consider the masses individually. That means we are going to break the system. System is going to be inside the system there are many masses, so they are going to be considered individually, right? So here in the system, okay, let me write this F1 and F2 and the force T and T. So now I'm going to break the system and consider the forces individually acting on the masses. So here it's M1. So T force, F2 force, T force, F2 force. Now when you consider this mass and the other mass, the tension forces are considered to be external forces. Now when you break the system, okay, when you break the system, internal forces become external forces. Internal forces become external forces, right? Why? Because we break the system. When you break the system, we individually consider the forces acting on individual masses. So we consider tension force as another external force. So now if you use F is equal ma to M2 mass, now separately you use F is equal ma. Here you use F is equal ma on M1 mass. Separately we use that. Now on M2, so we know that this is moving into the right hand direction. So that means motion is to the right hand direction. So T minus F2. T minus F2 is your F net. Right? So T minus F2 is equal to M2A. So acceleration of M2 and M1 would be the same because they are moving in the same acceleration. So this is our first equation. if you use a physical MA for the M1 mass, since it is moving in the right hand direction, so F2 minus T is equal to M1A. Okay, so this is the net force now acting on M1 mass. Okay, so if you want to find T or acceleration, so we can use these equations to find those values, but we will discuss those later. So in this question, first of all, we have to draw the forces we have. So we have tension forces, right? And then we need to find the acceleration of the system. So I will show you this in two methods. So method one would be I'm going to use a physical MA for the whole system. So when I use this for the whole system, what will happen? The internal forces are considered to be, the tension forces are considered to be internal forces, right? So internal forces are not going to be in a physical MA equation. Why? Because F would be external force, right? So F on the system would be F0. Mass on the system would be M1 plus M2. Acceleration of the system, so motion is to the right direction, so acceleration should be to the right direction, so it should be A. So acceleration would be F0 divided by M1 plus M2, and that's the answer, right? So this is very simple. So now method 2. So in method 2, what I will show you here is I'm going to break the system. So that means I'm going to consider the free body diagram. So on M1 you have T force. So on M2 you have F0 force as well as T in the other direction. So both are accelerating in a acceleration. So what I will do, I will use a physical MA on M1 object. So these are very important, right? On M1 object, this direction, this notation is very important. And a physical MA to M2 object to the right hand direction, very important. Now F on M1 would be T, M would be M1 A, and that is your first equation. For the second object, what is the F net force? That would be F0 minus T is equal to M2A. So that's your second equation. Now if you want to find A, what you can do is you can add those two equations, 1 plus 2. So if you do 1 plus 2, you can see T and minus T is going to cancel. So you get F0 is equal to M1 plus M2. So from there you get A is equal to F0 divided by M1 plus M2. So from there also you can find acceleration, you get the same answer. Now if you want to find the tension force, right? So to find the tension force, find the T force, what you can do, you can sub in this A value into one of the equation we derived, 1 or 2, right? So equation number 2 is very easy. So from second equation, from first equation, from the first equation, what you can find, T is equal to M time 1 times A. Acceleration would be F0 divided by M1 plus M2. So that's all about it. So okay, so in this question, first of all we had to draw the free body diagram. So fortunately we have only one mass here. Now here you have W, weight, and the reaction force or the normal force. The normal force is R, weight is W. Then if you want, you can resolve this way, right? So this is F0 cosine theta. Then there is another force this way, F0 sine theta. That is the vertical force, right? So now that is the free body diagram. Find the accelerator of the system. So I will use a physical MA on M mass horizontal direction. So F would be horizontal direction F0 cos theta is equal to M times acceleration acceleration in the horizontal direction. So acceleration would be f0 cos theta divided by m. Right? So that is your first equation. I mean, that is the answer. But I will take it as first equation. So the acceleration would be that. So now you have to explain why. You have to explain why there is no vertical motion. So now if you consider the vertical forces, vertically you have r, also you have f0 sine theta, down you have weight which is mg. So why there is no vertical motion? Because vertical forces are balancing each other, because vertical forces balance each other. You understand what I'm saying? Vertical forces balance each other. So that will tell you r plus f0 sine theta should be equal to mg, and that is the condition. Okay, so in this question, so first we have to find the acceleration. Now the surface has no friction, so we will mark down all the forces acting on these masses. So we have m2g going down. Tension force is here, right, always away from the object, right, T and T. Now obviously you have m1g here and you have normal force here, but now we will see what will contribute and what is not going to contribute. Now I'm going to use F is equal ma to m1 object. Now m1 object is moving to the right direction. This is very important. Then F is equal ma on m2 you use to the in the vertical direction. Now on m2, what is the net force? Net force would be m2g minus t. You can see this and that is counted. You have m2a. This is your first equation. Now you are using F is equal ma on m1 to the right direction. To the right direction, you see, to the right direction, what would be the net force? Just t is equal to m1a. That is my second equation. So on m1, it is true that you have normal force N as well as m1g, but you shouldn't be confused which force to be used. You have to know how to use F is equal to ma on which mass and in which direction. So if you have all these details, you can properly use it. So then in this case, N and m1g is irrelevant for the calculation. So now from 1 and 2, what you can do, you can add those two, then you can get the acceleration. So it would be m2g is equal to m1 plus m2 times a, and acceleration would be m2g divided by m1 plus m2. So that's the acceleration. So this is pretty clear. Now if you want to find tension, right, so you can, suppose this is equation number t. So from 3 and 2 equations, from 3 and 2, so you can find t, which is m1a. So a would be m2g divided by m1 plus m2. Okay, so in this question, so all the forces are marked, but there is a problem here. The problem here is, if you check capital M mass, I'm showing you T force and T force here, right? Is there any external force acting on this mass? No, there is no external force acting on this mass. If I draw T and T. So if there is no external force in this mass, there shouldn't be a motion. There shouldn't be a motion. There shouldn't be a motion. So we have to be very conscious when we are doing this. So we have to mark down T1, T1, T2, T2. Then we have a hope. T1 to the right hand side, T2 to the left hand side. So now T1 should be greater than T2 if you need to have a motion. That is very important to understand. Now what I will do, I will use F is equal MA individually. So here I am going to use F is equal MA to M2 object vertically up. Then second one, F is equal MA horizontally for capital M. Then F is equal MA M1 vertically down. So F is equal MA M2 up. That means T2 should be greater than M2G. So T2 minus M2G is equal to M2A. So for the capital M, you are using this equation horizontally. So that should be T1 minus T2 is equal to capital MA. So this is your second equation. So capital MG and N is not going to be contributed. Why? Because they are perpendicular to the direction of the motion. F is equal MA on M1. So that would be M1G, because M1G should be greater than T1. So that's why it is going down, is equal to M1A. So this is your third equation. Now if you have those three equations, what you can do is you can add all three together. So when you add all three together, T2 minus T2, T1 minus T1 will cancel. You will get M1G minus M2G is equal to M1 plus M2 plus capital M acceleration here. So acceleration can be found M1 minus M2 G, the whole thing divided by M1 plus M2 plus capital M. So that's the answer.